Artificial intelligence, it's on everyone's lips these days. I called it a top 6 topic for healthcare in 2023. But what is AI exactly? And can the big concepts be made practical in the real world? And can the potential downsides of AI, like amplification of bias and errors, be mitigated? Hi, everyone. I'm David Williams, president of strategy consulting firm Health Business Group and host of the HealthBiz podcast, a weekly show where I interview top healthcare leaders about their lives and careers. My guest today is Eric Landau. He's founder and CEO of Encore, which bills itself as a comprehensive AI-assisted active learning platform for computer vision. If you like this episode, please press that like button and subscribe. Eric, welcome to the HealthBiz podcast.
Thanks a lot, David. Very excited to be here.
Yeah, I love what you're doing with Encore. I want to talk about how you got there. Maybe just starting with your background, your upbringing, any childhood influences that have stuck with you.
Sure. So originally, I was actually born in Brazil. My parents are Brazilian. Most of my family lives in Brazil, but I moved to the United States when I was very young. So I grew up in California. And when I was a kid, I was always interested in science. So I studied physics at university. I started a PhD in physics. And all of the summer projects that I'd done, they were all research-based. So I was always working in some kind of accelerator, some kind of physics experiment. And during my PhD, I wanted to try the real world and see what a real job looked like. So I took a leave of absence from my PhD, and I started working in quantitative finance. And I'm still on that leave of absence. So it's been a very, very long leave of absence. Maybe one day I'll finish my PhD, but it's basically brought me to where I am now, which kind of took me through a detour of about a decade in quant finance and trading. And then I was lucky enough to meet my co-founder, Ulrich, who had the original idea for what Encore is now. And we started the company a few years ago, and now here we are.
Great. Okay. Well, that is a lightning trip through. You know, a lot of people from Brazil end up in Boston. I know some at MIT. So it's a common destination. But California is pretty good too, at least when there's not an atmospheric river going on.
Yes. It's funny that Brazilians end up in Boston because it's very diametrically opposed with regards to the weather. A lot more in California, and I'm actually in Miami at the moment. There are a lot of Brazilians here as well. It's a little bit closer to the temperatures that you would get in Rio or just kind of elsewhere in Brazil.
I guess it's a big country, so people could be all over the place. And we won't have the political censors come after us for talking about Brazilians in Florida in January of 2023. Nonetheless, so on the quantitative finance side, so did that tie in fairly directly to what you're doing in school with your PhD, and then did it have a connection with what you're doing now, or was it, as you said, just sort of like a detour that maybe was less related?
They're all kind of connected in an abstract sense, where in physics, in finance, and now running a startup, they're all about problem solving and being able to do that often in the absence of very good data. So being able to make decisions based off the available empirical evidence that you have and best judgment, and doing it in kind of a semi-quantitative way as well. So that kind of abstract problem-solving ability, which a lot of physicists kind of go through and try to figure out, okay, what is the best path through it, can be generally useful across a number of disciplines and workflows, but nothing in terms of the actual topic itself is really translated. So physics is a whole other set than quantitative finance, which is also quite different from computer vision, which is what we're doing now at Encore.
Great. Okay, perfect. So let's talk about Encore. But before that, I said, my introduction, what is AI? People have it as a word you're supposed to say, but then a lot of times I see it mentioned, say AI/machine learning, and, it's not differentiated at all. And you're talking about computer vision, which is, part of AI as well. Can you just start off maybe from the top and talk about what is AI? And how do these terms like machine learning, computer vision, even some things that people might consider sort of on the edge of AI, like robotic process automation, a big topic in healthcare. How do you think of those things, broadly? And then maybe where does computer vision fit within that taxonomy?
Yeah. So I think the conceptual framework to think about AI in is in comparison to traditional software programming. And what I like to say is that AI is just basically computers solving complex problems through showing, not telling. So what does that mean? Okay, a complex problem, it's hard to define that very specifically, but just something that is hard for a computer naturally to do, or is not something that is like very, very simple or straightforward. And showing, not telling, uh, the way that traditional software works is computer programmers will write these programs and they'll deterministically define the behavior of a computer to do a thing. So if this happens, then do this. If that happens, then do that. And it tries to enumerate the contingencies in a way, whereas AI just does it by showing. So instead of telling the computer, hey, in all these circumstances, go and do this and this and this, actually just look at some desired outcomes and then try to learn what the desired outcomes should be and then try to replicate them in a new context. So showing, not telling is really the key between um, artificial intelligence and traditional software. And then complexity is what makes it interesting. So solving, you know, problems that are non-trivial and then within that conceptual framework, there's a lot of kind of subcategories. I think the one that's relevant, at least for the discussion today, is computer vision. And that's anything that a computer can do that is related to visual media. So something that humans would react with our eyes. And that could be through videos, through images, through medical images, so CT scans, MRI. So these are volumetric images, but the way that people interpret it is essentially through their eyeballs. So computer vision is just something that we visually interpret and within this framework of solving complex problems by showing.
Got it. So if I think about computer vision, well, we don't want it to be completely clear, but it's pretty clear. So on the computer vision, if I think about that element of it, it's something like it's something that I could see. I could look at it and say there's some kind of a pattern there, maybe, or I can't see it, or maybe I see certain things, but I know it's more complicated, or even I think I see everything, but maybe there's something more behind that. And that's sort of what computer vision can do, like to kind of take the vision to the next level. So if you had like super incredible vision, in some ways, I think computer vision is easier to understand than machine learning. Um, as its overall
Yeah,
concept. And if I understand right,
yeah,
on machine learning, one of the things that's been an issue is this sort of this supervised versus unsupervised machine learning. And I think on the supervised one, where a lot of the models have been, you sort of get bogged down. I know some clients I've dealt with have had sort of trouble. They try it, but there's a lot of work that needs to be done before you can actually let the machine go on it. Is that right?
yeah, yeah. That's exactly right. So just like a quick heuristic on the last point, computer vision. If a human were to interpret the data, it would be through their eyeballs. So, and then anything that is within the computer vision realm. And on unsupervised versus supervised learning. So back to like the showing, not telling.
Yeah.
So supervised learning is showing the computer both the data and particular labels on the data. So you show it, here's a cup, and you tell it that that is a cup. Whereas unsupervised learning is just showing it the data. So you don't tell what the different elements are, but the computer can still learn interesting patterns and things that are useful just by looking at the data by itself without enumerating particular attributes to it.
Got it. Okay, that sounds good. So if I think about some of the opportunities and the challenges in making AI into something practical, because I think it's always something that's been done in academic institutions, you could demonstrate it and so on, but like to really make it something that's in the real world. What are some of the maybe the like the big high level opportunities, and then what are some of the challenges to actually make it practical?
Yeah. So the biggest challenge so far has been on the data layer. So we have a ton of data, and especially if we're talking in the context of healthcare and medical institutions, they're sitting on a lot of data. The problem is that it's not structured in a way that computers can learn from it easily. So it requires processing, it requires cleaning, it requires curating, it requires labeling. all these steps that are required for the computer to actually take the data and then translate it into something that can be economically, or commercially, or societally beneficial are the existing bottlenecks that we have right now. And one of the reasons is that just the tools for working with this data haven't really been developed properly so far because we're so early in this space. So really figuring out how to crack this data layer is the key element to getting these models to actually work at the standard and levels that we want them to be comfortable in production environments. And there's a lot of kind of sub problems there, but
Yeah.
that's kind of the high level
Okay.
conceptual bottleneck that we have
So
now.
when you think about some of the approaches for machine learning and computer vision are great if you have the right data set, but there's a lot that needs to be done to the data to make it, more pristine, less dirty, whatever the sort of things that need to have to happen to be able to use it. So if you think about where the advances need to occur from your perspective, it's less, of course, there's always more to do on the models, but it's actually the data layer as you're describing it.
That's exactly right. And this highlights a shift from what is called model-centric AI to what's called data-centric AI. And model-centric AI is people just working on the model, just focusing on the model. And the
Yeah.
reason that it's, traditional machine learning development has been model-centric so far is because the way that it's being done in academia is you have these benchmark data sets that are just created, like a fixed amount of data with a fixed set of labels. And the only thing that researchers are able to change is the model. So they're not able to change the data sets because those are fixed and they all benchmark against each other. But in a practical environment, you can train a model perfectly for a specific data set. But when it goes into the real world, the data changes, right? And you see patients of different demographics, and you see drift in the populations over time. And if you don't have things to account for the shifts and kind of the dynamism that happens with like a real production environment, then your model is just inevitably going to fail. So instead, you have to focus on how do we continuously improve the data and figuring out how to get the data to work for the model such that it's well matched to the environment that's actually being deployed in. And that's a realization that's only happened, I think, from a practical perspective in the last few years. So we're still quite early on that, but I think this is going to be one of the keys to getting these models to work at scale in production environments.
One of the problems people talk about with AI that I've heard over the last couple of years, and I think now this is generally in people's minds, there's a bias. Now, can you describe, if you agree with that, like what the kind of bias we're talking about, and is it in the models? Is it in the data? Is it how that when you are not dealing with the data and you try to adjust the model that you introduce bias that way? What help me understand better the bias question?
Yeah, that's a great question. And that is a function of the data, really, because it's the same issue where you have a fixed data set. And oftentimes, the way that people have collected these data sets historically is they go to wealthy institutions or ones that have had the infrastructure to not only collect but label this data. And so the type of again, in a healthcare environment, the types of patients that are reflected within that data set are not representative of the broader world. So a model is only as good as the data that you're feeding it. So if you feed it a bunch of data from a particular segment of the population, it will learn to that segment of the population, but it won't know about the other parts of the population. So once you actually put it into the real world, it's just bound to fail. So we have to match the data that we are giving these models to ones in which to the environments that they're actually going to be working in. And that's this kind of data-centric perspective. And that is really the best way to overcome this bias problem. If you give it the right data, the bias problem will kind of take care of itself.
Got it. Okay, so you've been talking about how the industry is at an early stage of really going from kind of academia to making it practical, especially in healthcare, and there's a lack of tools to be able to do that. And if I look at what you're doing as an offering for your company, I'm seeing a set of things: annotate, automate, evaluate, manage, label. How does that fit in with sort of the concept of overall what sort of tooling is needed?
Yeah, it's really to solve this problem of taking these massive masses of unstructured data and converting that into data sets that can actually work for a model. And the biggest component there is labeling the data, because most models are currently in this supervised paradigm,
Yeah.
where in a gastroenterology video, you have a bunch of video going in a colonoscopy, you see a polyp. Um, you probably want to say whether that's a cancerous polyp or not, so that when the model sees a future polyp, it knows to pattern match to ones that it has seen as cancerous. So the process of then going and labeling, okay, this is a cancerous polyp, this is not, this is a cancerous polyp, this is not, that is currently very, very inefficient. The tools for that just historically have not been very good, which was one of the reasons, that was where we started the company with, is to make that annotation process a lot more efficient, a lot less painful for the people doing the labeling, which are often physicians, and something that can work at scale for machine learning engineers as well, to work with these much larger data sets to train good models.
Got it. So I want to talk about healthcare and what some of the opportunities and use cases are there. But before that, I'm just curious about like outside of healthcare, where do you see the opportunities? What are you working on?
I mean, we work in a variety of verticals, so retail, geospatial, autonomous vehicles, agriculture, but our single biggest vertical is in healthcare, and within healthcare, that's also quite wide.
Yeah.
So there's gastroenterology, microscopy, radiology, ultrasound, and radiology is our single biggest kind of sub vertical within healthcare. So computer vision, as the models and the data sets and the tools around these things are improving, we're going to see it proliferate across many different elements of our lives. I think healthcare is one of the more exciting ones, which is why it's one of the ones that we're focusing on as a company. But we're not limited just to that. We also work in other use cases as well.
Got it. Okay, so let's talk within healthcare, and it sounds like you mentioned the GI example. Are these all things that are sort of related to medical imaging and the different modalities of medical imaging? So it sort of traces across there. Is that right?
Exactly. That's exactly right. Yeah.
Yeah. So if we look at the GI one, you've got the example of doing the labeling for colonoscopy, which you're right, as you've seen, it's like a long video because there's a big procedure, and it's the probe is going through and reporting back a lot of information that you've got to annotate. What are some other areas that are different from that one?
Yeah. So radiology is a big one. So annotating on CT scans, MRIs, X-rays. One of the things that we're quite proud of is we built a DICOM tool.
Yeah.
So kind of a pack style interface that you can annotate these different radiology modalities quite easily. One thing that we've noticed is that physicians, radiologists, they're quite used to the workflows that they have
Yeah.
within their clinical settings, and if you kind of deviate from those workflows, then it's not as efficient, and it's also
Right.
more painful for them, and there's a learning curve. So we spent a lot of time talking to a bunch of doctors and refining an interface that works well for them, so that they get onto our annotation tool, and it kind of looks like the PACS viewer that they
Yeah.
have, and so the muscle memory is there, and they can go through data a lot quicker. So that's one of our biggest focus points is in radiology, and that's also where AI is currently the most developed within the at least the healthcare diagnostic world.
Got it. So the DICOM is sort of like the standard format for medical images, and then the PACS system is where people use it as a viewer. So if I'm a radiologist and I'm doing some labeling, what you're saying is that I'm getting something that looks like the same input as though I were just looking at a given patient and doing a report, and I'm going to also mark it sort of the same way that I do when I'm producing one of those reports as well. But it's for this purpose of the labeling for the training the data set.
That's exactly right. Yeah.
So what has happened? I alluded to before. A lot of people want to use AI, but they haven't really had a chance to do it practically. Once they go ahead and go and do the labeling, go on your platform, what can then they achieve? Like, what would be a case study to say, this is what it's like before, and this is what it's like after that I can now do?
Yeah. One of the example case studies we did a paper with King's College London in the gastroenterology department. And there we A/B tested our platform versus what the most common alternative that people use. And what we found was that with our approach, they were able, on average, to label 6.5 times faster than what they were doing before. And about 97% of the labels ended up being automated. The quality was better than what they had before. And for the most senior physician, it was actually 16 times faster. So as the seniority increased, the efficiency gains that you got were also improved. Maybe for some of the reasons that we touched on before, where kind of other systems are not really optimized with kind of doctors' flows in mind. So with that, they were able to get through a lot of labels much quicker, and then can train a model much quicker and can iterate on the model with respect to the data much quicker. So the end result at the end of the day is if you get labels a lot faster at a higher quality, you're able to create better models, which will then drive patient outcomes or essentially just be much better in the wild once you actually run them versus waiting for more data and waiting to train. So we want to just speed up the process to get these models into production and into real world value.
Can we dig in a little bit on that comment that you made, if I understood it right, about that you get a higher productivity boost for the more senior people, like a 16x versus a 6x? That's counterintuitive if I've understood it right, because to me, the most, what I would say, and then you can tell me why this isn't the case. Most senior person is going to more closely match the potential, whereas the more junior person sort of can be brought up to a higher level. So I expect a higher, multiple of them. So what have I not understood?
Yeah. So the paper, what we did was we showed one of our automated strategies in the actual tool, and so the difference is essentially between kind of a mostly automated approach with a review component for us versus the most common other alternative is a completely manual approach. And what we found was that both the junior and the senior people, they got up to similar levels with us because the computer is doing most of the work. So all they're doing at the end of the day is they're just doing reviews, which for the most senior people, they can do the reviews faster because they've seen a bunch more examples. They can pattern match quicker than more junior ones. But then for the manual piece, because it's a system which is uncommon, especially for senior people, the learning curve, I think, is steeper because they're more entrenched in the ways that they kind of normally do these medical flows. Whereas the more junior people, I think their learning curve was a little bit faster on this other tool that was completely manual. So that's probably what I would attribute the gap to. But we'd have to go back and look at the data and give like a full analysis on that.
I think this wasn't the purpose of the paper, but it provides, I think, some insights. This type of thinking for a broader kind of management of the workforce. It's so difficult there's shortages in every area that you look at, and one reason is people are not optimally deployed. And so, if you see what sort of tools are actually useful for people at different stages and different skill levels, and even I know these are all within physicians and just how senior they are, but even for, let's say, a physician versus a nurse practitioner, a PA, a tech, pharmacist, whatever, having the right tools to the right roles, it may be sort of enhancing productivity and possibly even sort of the quality of the experience for them could have a real impact more broadly, which goes beyond what you're discussing here, but I think it's a good implication.
No, I think that's very relevant.
So the company sounds like you're still at a relatively early stage. What have you done up to this point in terms of funding, in terms of your business model, and what's not your computer vision, but your Eric human vision in terms of where you're going to be in, let's say, 3 to 5 years, whatever the time frame?
Yeah. So for the history of the company, we started during the pandemic. Essentially, we built the first iteration of the product between my co-founder and I. And then we went through an accelerator program in the US called Y Combinator. It's a kind of a famous accelerator that has a lot of great companies that have gone through it. And then we're able to raise a couple rounds of fundraising after Y Combinator. So got well capitalized during 2021. And the focus in the last year and a half has really been in kind of growing the team, improving the product, and growing the market presence. And right now we're at a pretty good position for most of those things. But what we've noticed is because we're based in the UK, so most of our operations are from London, is that we haven't had as much US presence as we could. So now the next iteration is to grow our market presence also in the US market, not just in Europe, Israel, Asia, and Australia. So that's kind of the short to medium term goals that we're seeing. It's one of the reasons I'm in the US right now, not just enjoying the sunny weather here compared to the darkness in London. Is we're looking to hire more and expand geographically. And then in terms of the longer term vision, 3 to 5 year horizon, we see this is really an opportunity to set up these tools and processes for not just the data component, but also for really getting models from this unstructured data through to a production environment, and then through like a full kind of monitoring and improvement cycle. It's what's called active learning. So building a full active learning pipeline where models can learn continuously and improve continuously over time, such that they're always getting better. Right now models are very static. You send it out and then it doesn't learn from new data unless you explicitly tell it to. So getting the tools in place such that there can be incremental learning and they're almost like real world doctors or real world people. That's where we see this thing going, and that's where we're kind of building towards as well.
Great. So final question is if you've had a chance to read any good books lately, anything you would recommend or recommend to avoid?
Well, the most recent thing I've been reading has been a book by Terence Tao. So he is one of the greatest, or if not the greatest, living mathematician. Now he has kind of a collected set of his posts. One of this aggregation is called Symmetry Spending, and it just goes through a bunch of different topics in mathematics. And what's amazing is how broad and deep he is within many different areas of math, and the different types of insights, and how he thinks about even sometimes societal problems with respect to mathematical thinking. Of course, like there's a lot of math jargon in there, so I don't know if I would necessarily recommend, but I think it's definitely interesting from reading the thoughts of some of the smartest people in the world. A book that I would recommend, one that comes up at the top of my mind is a book called Super Forecasting by Philip Tetlock.
Yeah.
So it shows how often experts are wrong and how you can really improve your judgment and processes for thinking about the next steps in the world and macro events as well. I think that's a very, very nice book that I read not too long ago.
Now, I haven't read that book, but I do sometimes my predictions for the year, and I share them with different folks, and most people like them and they say great. And then one person I sent it to who's got more your background in terms of training said, yeah, your predictions they're no good, and I'm not even going to bother with them. You should read this book instead and see how to do it. But they didn't understand that my purpose is not to be a super forecaster, but to generate conversations for business development. So that's where he and I differ. But
I do the same. I do predictions every year, and one of the reasons I do it is to limit hubris, because if you do predictions every year, you realize how often you're wrong. It's like,
yeah.
Oh man. One of the telling examples was in the predictions that I did in 2020, very early in 2020. I got it from a bunch of people. 0 people predicted COVID. COVID was already known. It was a known entity, so It was in the news. But 0 people predicted that it would be a pandemic at the level of what we actually saw. So it's always good to be humbled by how the real world actually operates.
Good. Well, I'm not going to predict your success or lack thereof then, but I hope it does work out well for you, Eric. So my guest today has been Eric Landau. He's founder and CEO of Encore. We've been talking about artificial intelligence and a whole lot more. Eric, thank you for joining me today on the HealthBiz podcast.
Yeah, thanks a lot, David.
You've been listening to the HealthBiz podcast with me, David Williams, president of Health Business Group. I conduct in-depth interviews with leaders in healthcare business and policy. If you like what you hear, go ahead and subscribe on your favorite service. While you're at it, go ahead and subscribe on your second and third favorite services as well. There's more good stuff to come, and you won't want to miss an episode. If your organization is seeking strategy consulting services in healthcare, check out our website, healthbusinessgroup.com.